Okay, the quick pull today is we're going to do 17 plus a negative 22. Figure out the value of that. Pause the recording until you have that figured out. All right, and according to the quick pull, every student in this class got it correct. The value is equal to -5. Ways that we can model this. These are pretty big numbers, so I don't want to draw 17 positive tiles and then 22 negative tiles and then find the zero pairs. So for something like this, I think it makes a little bit more sense to sketch a number line. And my number line is not going to be perfect, but it is going to look something like this. That if I have 17 balloons, it's going to go up 17. And if I have 22 rocks, from there it's going to go down 22. But what I'm also thinking about is how whenever there's overlap, those are the zero pairs, which means the first bit that it goes down is 17. Those are those zero pairs. I need to go down the rest of the way to get to 22. So 17, 18, 19, 20, 21, 22. Oops. That is how I can model that -5 there. So again, it's not a perfect number line, but it's just enough of a sketch that I can show what my thought process is without having to draw all the way down or all the way up to 17. So today we're going to be talking about Unit 5, Lesson 4, Money and Debts from Open Up Resources. When we're talking about money and debts, this is applying what we know about signed numbers to money. And this is where we're going to start seeing some really large numbers. When we have talked about temperature and elevation in the past, yes, we can have some pretty high and pretty low temperatures, pretty high and pretty low elevations, but we typically don't see those amounts quite as big as when we're talking about money and debts. So now we get the chance to practice our skill that we have been building with our counters and our number lines and put it to practice using a lot bigger numbers, really trying to get away from those physical models and start doing some of this a little bit more mentally because we're forced to with these bigger numbers. So the first little section is kind of a little bit of a warm-up section, concert tickets. Priya wants to buy 3 tickets for a concert. She has earned $135 and each ticket costs $50. She borrows the rest of the money she needs from a bank and buys the tickets. So questions 1 through 3 with your groups. How can you represent the amount of money that Priya has after she's done buying the tickets? How much more money will Priya need to earn to pay back the money that she borrowed from the bank? And how much money will she have after she pays back the money that she borrowed from the bank? With your groups, I want you to work through these 3 problems. I'm going to pause the recording as students work in their groups. Ready, set, go. Okay, how can we represent the amount of money that Priya has after buying the tickets? How do we, and you can represent it with an expression, you can represent it with a number line, you can represent it with a number, the final result. How do we get there? How do we show that? I'll wait until there's more hands because you guys had a lot of time to discuss. Do you need more time to discuss? Okay, let's see those hands. Sophie, will you start us off, please? Oh, 150. Why 150? Okay, but it says that the tickets cost just $50. Good. Yep. Good catch. So we're buying 3 tickets. Each ticket is $50. That's why it's 3 times 50 is 150. And so that's also why we can go 135 minus 150. There's another way we can represent this too. What's another way we could represent this, Joshua? Okay. Mm-hmm. Good. So tying that in, sketching out my number line, which is still just a rough sketch, tying that into with what Sophie suggested, 135 minus 50 is equal to -15. But this sketch, doesn't that look a lot like how we represented addition? Yeah, this is a subtraction problem, isn't it? So how else can I represent this? Just wanting to make lots of different connections here. Tie it into our addition that we have been doing. Gideon? Exactly, plus a -150. Because A negative number represents the amount that we are spending. You can also represent the amount that you're spending by subtracting. That's fine as well. That's probably what we're more familiar with, but just trying to make some connections to what we've already done previously. Either way, the end result is negative 15. So how much more money will Priya need to earn in order to pay back the money that she borrowed from the bank? She had 135, spent 150, so she's in debt with the bank $15. How much money does she need to pay the bank back? Let's think about what this is saying. She is in debt $15. She needs to pay back a certain amount so that she now has $0 of debt. Tanner. Yeah, she has to pay $15 back. And then number 3 is so very, very, very closely related to number 2 that it almost made it a little bit hard, because you're like, wait, what? How much money will she have after she pays back the money that she borrowed from the bank? Well, negative 15 plus 15 is equal to $0. So she's going to just zero it out. She's not going to have any extra money. Nope. So she better go and do some more babysitting so that she can buy that candy bar that she wants at the store. Okay, next section. Cafeteria food debt. At the beginning of the month, Kiran had $24 in his school cafeteria account. Use a variable to represent the unknown quantity in each transaction below and write an equation to represent it. Then represent each transaction on a number line. Then we're going to find out what the unknown quantity is in each case. This is kind of increasing the difficulty a step because now we're introducing variables to represent the unknown. But if you look, I kind of did the same thing here. A variable is really truly just a symbol for an unknown quantity. I used the symbol of a fill in the blank sort of a line. That was still a variable. You were able to answer that pretty quickly. This time, the variables that we use, maybe we'll use some letters instead of just fill in the blank lines. But I want us to try and solve these thinking through them. So in the first week, he spent $16 on lunches. Oh, sorry, remember, at the beginning of the month, Kiran had $24 in his school cafeteria account. The first week he spent $16 on lunches. How much was in his account then? So this part here, how much was in his account then, this part is the unknown. Sometimes the unknown is going to be at the end of our equation, the end of our sentence, instead of in the middle. So just give that a try, just a few seconds discussing with your group, just so I can kind of pre-assess where we're at and how much longer we need to spend on this. Go ahead with your groups. Ready, set, go. And pausing the recording. All right, as I worked my way around the room, I saw some really good things here. The equation, we're starting with 24. You can do this a couple of different ways. You can write minus 16. We're making some connections to what's coming up in the future. You can write 24 plus a negative 16, making connections to what we've just been doing. But this is not yet an equation. We need to write an equation, which means we need to figure out what this is equal to. That is the unknown. So I'm choosing for it to be equal to X. Other students chose for it to be equal to F for the first week, or S for how much he spent. And all of those are perfectly acceptable variables and doesn't always have to be equal to X. Either case, whether you did 24 plus a negative 16 or 24 minus 16, turn it into an equation by saying it is equal to this unknown value, and then take that extra step. What is the unknown value? You know that the unknown value is 8. Now, x equals 8 is abstract. If we want to turn that abstract answer into quantitative, how much was in his account then? That's when we say $8 in his account. Making that connection to math practice 2. All right, then he deposited some more money and his account balance was 28. We need to have a conversation about this word. This is an easily misunderstood word by many 7th graders. What does deposit mean? Luke? Yes, he is adding money to his account. And almost every single year, I have about half of the students say that it means it's a deduction. It's decreasing. Why do you think students would make that mistake? Let's critique their reasoning. Why would students say a deposit is a decrease in money? Any thoughts? Grant, what do you think? Yep. That's exactly the reason why. They see this DE, depreciation, or deduct points. All those things mean negative things. So deposit is adding money to our account, but some students see it as a negative thing because it's now less money that they have in their pocket, right? And so that's kind of where that comes from, but we're not... Exactly. And so since we're talking about a deposit into the account, we're focused on how it affects that account, not how it affects what's in our actual pocket. So he deposited some more money into his account and his balance was now 28. Oh, I skipped the part where I said, don't forget, we're supposed to be doing a number line. On a number line, this would look something like we're starting from 0 to 24. And then we are deducting 16. Which gets us to that value of 8. And now he deposited some more money in his account, and so now his balance is 28. The question is, how much did he deposit? The equation here is going to look a little bit different. And as I walked around the room, I saw that there were some answers. Who is ready to actually answer this with that equation written? Go ahead, Joshua. Yes, 8 plus x equals 28. This time, I'm going to use a different variable. Since I did use x above, I'm going to use a different variable just so that it doesn't get to be confusing. We could. I normally like to avoid x2 for other reasons. But let's say d for deposit since we are depositing. 8 plus d is equal to 28. So what would d have to be? $20. D is 20. Or we could say $20 deposited. And that number line can also help us. We know now that we're starting at 8. I'm somehow making it all the way up here to 28. How is that happening? Well, because we are depositing 20. So there's another number line model to kind of show that. Do we need a little bit more time to work on 3, 4, and 5 based on what we've done, or are we ready to continue to discuss? Good to discuss. All right, then Dylan. Then he spent $34 on lunches the next week. How much was in his account then? What would I do here? What's that equation going to look like? Good, 28, because he deposited 20 and now is at 28. Good. Yep. Good. Great connection. 28 plus a negative 34 or 28 minus 34. And making it an equation, this is going to be equal to, go ahead, choose a variable. Variable first, because we're writing equations. Yeah. A, good. Any reason? No, okay. Just a good letter. Yes, is equal to A. And you've also done that calculation. A then is equal to, what was it? Negative 4. It would be negative 6. But will you please construct a viable argument to show that it would be negative 6 and not negative 4? Why? Why is it negative 6?
It's because he was just taking the ones place and then just saying that was it. But it's not 30, it's 28. So you have to add that 2. That would make it a 30.
Okay. Another great way that we could argue this case is with a number line, right? If we're starting here at 28, we're spending $34. So let's figure out exactly where that's going to leave us. Remember, we kind of talked about this with our warm-up. The first $28 here, that's just going to zero out that account. But he spent more than that. So 28, 29, 30, 31, 32, 33, 34. I didn't draw my arrow quite long enough. So now I can see 1, 2, 3, 4, 5, 6 hops below 0. A is equal to negative 6, or in other words, he is in debt negative $6, or owes $6 more. Again, notice the words that we use to represent that negative. Negative, quantitatively, we would say he owes or is in debt that $6. Then he deposited enough money to pay off his debt to the cafeteria. So how much did he deposit? That equation is going to look like this. He is in debt $6. He's depositing a certain amount. Let's maybe use the variable B this time. And now he's just paying off his debt, so the end result is going to be 0. What would that be have to be equal to? A positive 6, yeah, positive 6. Or in other words, he deposits $6. And again, a number line to show that. Here's 0. Here's the negative 6 that he's in. He's just going back to pay off the debt, so he's only adding the exact amount to get him to 0, or in other words, $6. And now just a quick discussion. Why does it make sense to use a negative number to represent Kiran's account balance when he owes money? Why are we using negative numbers here? What are your thoughts? I want to see some fresh new hands that I haven't yet called on today. I think, go ahead, Grant. Mm-hmm. Yeah. Good. And making that connection to before, when we were using our positive and negative numbers to represent elevation or temperature, negative numbers represented temperatures below 0, or negative numbers represented elevations below sea level. And now we're going to be using negative numbers to represent amounts below $0. We have to represent them different than when they're positive, when we actually have money. Okay. And to the next one. Real life applications here. This is very quantitative. This is a bank statement. Anybody have their own bank accounts and get these bank statements occasionally? Good. Do you know how to read them? Awesome. That's great. So again, understanding these words, we know that a deposit is money added to the account. And it could be added for a couple different reasons. It could be added to your account from your employer because your employer is paying you. It could be added to your account because you got a check for babysitting, and so you're depositing that babysitting money into your account. This word right here, withdrawal. What does a withdrawal mean? Oren? Yep, this is money that's taken out. Why might money be taken out of an account? Luke?
Because you need money to go buy concerts.
Yeah, exactly, because you need to take money out of your account so you can go buy concert tickets. You're going to spend money, usually, is what's happening, which is why we see things like point of sale, grocery store, meaning they spent money at the grocery store. So if we put withdrawals and deposits in the same column, how can they be represented? So again, we know that withdrawals, you can see they have their own column here. That's money taken out. Deposits have their own column. That's money that's added in. So what if I decided to make this a little bit simpler and I wanted them in the same column? How would I need to represent each situation? Leroya? Yep, if we put them in the same column, we would have to use negative numbers to show that this is money that is taken out. And if I'm going to use negative numbers to show the withdrawals, what should I do for the deposits? What are your thoughts there, Gideon? We could use positive numbers. Now, my question to you is this. Aren't these already positive numbers? So do I need to use a positive sign? No, because mathematicians are lazy. So will you maybe sometimes see it? Yes. Are you always going to see that positive symbol? No. So let's make sure we mention that when it is a deposit, it may or may not have that positive sign. Just remember, when it does not have that positive sign, we still assume that it's positive. unless other information is given to us that tells us otherwise. For example, if we have a column labeled withdrawal and all we see are positive numbers, but it's in a withdrawal column, that's when we can assume that they really are negatives. They're coming out. All right, so this is Andre's account. Andre withdraws $40 to buy a music player. What is his new balance? And then finish that up. If Andre deposits $100 in his account, will he still be in debt? How do you know? So talk with your groups, answer those questions. Ready, set, go. And pausing the recording. All right, what's Andre's account balance before he buys that $40 music player? Alexis? So he has $62 in debt, right? So he already owes $62.47. He's already in debt that much. And what's happening now when he withdraws $40? First of all, is the bank really going to let him do that? Probably not. Not too many will. What is it, Luke?
His account balance would change to $102.47.
Good. So we're withdrawing an extra $40, and now his account balance is, say that number again.
$102.47.
In the hole, right? In debt. Yeah, negative $102.47. Luke, your hand is still up. You have another comment?
No, I can do the next question.
You want to do the next one too? Let's see if there's anyone else who wants to. We know his new balance is negative $102.47. So if he deposits $100 in his account, is he still going to be in debt? Yeah, he is. How do you know he's going to be in debt? Leroya.
He still owes $2.47.
Yep. Negative $102.47 plus a $100 deposit is still going to leave him in debt $2.47. He is more in debt than what he is paying off. So yes, he is still going to be in debt. Yep. Squeeze in one more lawn mowing before the season changes and he has to start shoveling sidewalks. This one is a really cool one. I really like this one, but it's not one that we're able to do right now. It says the national debt of a country is the total amount of money the government of that country owes. Imagine everyone in the United States was asked to help pay off the national debt. How much would each person have to pay? A lot. A scary, crazy, insane, ridiculous amount. I want you, this is just, it's not extra credit. It's not just, if you're interested, look up the national debt, look up the population, see what each person would have to pay. And we're talking each person. We're talking even that newborn baby that counts as a person, as well as the 98-year-old man who's retired and living on Social Security. That's what the population is. So if you want to have a good time and hear about just how scary our national debt situation is, go ahead and do the research on that one.
I mean, I could.
But for right now, we're going to summarize. The lesson 4 summary. Banks use positive numbers to represent money that gets put into an account and negative numbers to represent money that is taken out of an account. When you put money into an account, it is called a deposit. When you take money out of an account, it's called a withdrawal. People also use negative numbers to represent debt. If you take out more money from your account than you put in, then you owe the bank money, and your account balance will be a negative number to represent that debt. For example, if you have $200 in your bank account, and then you write a check for $300, do you guys know what that means? Write a check? Have you guys seen that happen in your lifetime? You guys are so young and checks are almost obsolete now. Yeah? A check for your birthday from grandma and a card probably? Yeah. That's so funny. Okay, anyway, back to voices off. I would be willing to bet that they probably don't even teach you how to write checks anymore because they're just not a thing that much. Anyway, if that happens, if you write a check for $300 and you only have $200 in your account, then you're going to owe the bank $100. Plus, then the bank is also going to charge you some fees and all these other things too. So probably you'll end up owing more. So again, we can read this account balance. We started at 0, deposit of 50. I know that it's a deposit because there isn't a positive sign, but we can assume it's positive. So our new balance, 0 plus 50, new balance is 50. And we deposit 150. Again, there's not a sign, so I can go ahead and assume that that's positive. 50 plus 150 is 200, so our new starting balance is 200. And now, negative 300. We can see that negative sign. That tells us that it is going to be a withdrawal. 200 plus a negative 300, or 200 minus 300, leaves us with our starting balance of being in debt $100. In general, you can find a new account balance by adding the value of the deposit or withdrawal to it. So, as much as you wanted to think about these problems as subtraction, I want you to recognize, so that we can start making some connections, you can add the value. Just know that if we're adding a withdrawal, we're adding a negative number. New glossary terms that we have been talking about this lesson: deposit and withdrawal, and now it is time for our cool down. Claire has $150 in her bank account. She buys a bike for $200. What is Claire's account balance now? And question 2, if Claire earns $75 next week from delivering newspapers and deposits it into her account, what will her account balance be then? Do this one independently. I don't want you to talk with your groups on this one. Do this one independently, kind of self-assess. I'm going to pause the recording so you have a chance to work on this on your own. All right, just checking our answers here. $150. She's buying a bike, so I'm going to do plus a negative 200. Yes, we also could have represented this as 150 minus 200. Either way, the end result is negative 50. And we're going to take that to the next problem, negative 50. She's earning $75 from her newspaper route, and so now her account balance is $25. Making those abstract answers quantitative by including the units of measure, $25 and owes $50. Your homework is Lesson 754, Practice Problems. On this homework assignment, you'll see that there are some other topics besides just integers and positives and negatives. We have some stuff with proportions, positives and negatives, percentages, more positives and negatives. So make sure you're answering each question. That's it for today. Thanks for watching.